Okay, hello everyone. My name is Yusuf, and I'm gonna talk about the sine cosine algorithm in artificial intelligence. So it's a meta-heuristic and population-based optimization algorithm, and it's inspired by maths, especially sine and cosine functions. So it's meta-heuristic algorithm because it's used for general optimization purposes instead of a specific optimization problem such as path planning. And it's also population based algorithm because it uses a population, which is a set of solutions. Okay, um, let me tell you main steps of the algorithm. And firstly, we gotta define the problem parameters, such as cost function, dimension, and lower bound and upper bounds, right? So dimension is the number of the decision variables in a solution, and lower bound and upper bound are the boundaries of the decision variables or search space. And next step, setting the control parameters of SCA, maximum number of iteration, population size, and just A, which is a specific control parameter of the algorithm, and setting to 2 commonly. The next step, creating a population randomly, right? So the population is a matrix of size n by d, which means number of solution or population size by dimension of the problem. So the next step is finding the best solution and the best cost in the population. And the next step is main loop or iterative loop, right? So in the iterative loop, firstly, for each iteration, we gotta update the parameter R1, which is the iterative parameter in SCA, and calculated by using this formula, A minus T times A divided by capital T. T is the current iteration, capital T is the maximum number of iteration. So the next one, for each solution and each iteration, we gotta update R2, R3, and R4, which are random numbers in the range of specific intervals. After that, we gotta update the solutions using the equations mentioned in the paper or article of the algorithm. And these are based on sine and cosine based equations. After that, we gotta control the solutions whether they are inside the boundaries, right? So after that, next step is evaluating the new population for each solution using the cost function or objective function, and updating the best solution and the best cost, right? So until the stopping criteria is met, the iterative loop is repeat, and after the main loop or iterative loop, we're gonna report the results, which mean best solution and the best cost. Okay, so let's get the coding. Okay, let's start coding, and I'm creating a new script named SCA, and I'm typing the resetting commands in MATLAB. CIS clear and close all. And firstly, we gotta define the problem parameters. Right, such as cost function, cost function, dimension, lower bound and upper bound. Okay, and cost function, I'm gonna use the spare function as a cost function or objective function, and it's a simply benchmark function in optimization, and formula is here. F of x equals I equals 1 to d xi squared. So d is the dimension, and lower bound and upper bound is here for each dimension. Okay, cost function. We gotta define the cost function. We gotta define the spare function in MATLAB, and at the bottom, I'm typing function loop, right? And define cost function. So f equals spare x, and it's here, and the summation I equals 1 to d xi squared. Okay, so f equals 0 initially, and for I equals 1 to len x, which means the dimension of the decision variables, and f equals f plus xi squared. Or you can also write in short f equals sum x dot square, right? So it's a representation of the spare function in short, and you can use this function, or you can use this calculation, right? Okay, so cost function is the spare function at spare. Okay, so dimension is the number of decision variables of the problem, and it's up to us for the spare function, and I'm setting to 10. So lower bound and upper bound is here, minus 5.12 to positive 5.12, and minus 5.12 and positive 1, so positive 5.12. Okay, next one, the next step, setting the control parameters of SCA. Control parameters, the set control parameters, and firstly maximum number of iteration, and 1000 for now, and population size, and 30 for now, and specific control parameter A equals 2. Okay, next step, create a population randomly. Population, which means a set of solutions, and randomly. Okay, population equals lower bound plus upper bound minus lower bound times rand, and population is a matrix of size n by d, or population size by dimension. Population size by dimension, right? So let's run the code and look at the population. It's a matrix of size 30 by 10, right? So each row represents a solution, and each column represents a dimension of the problem, or dimension of the decision variables. Okay, next step, evaluating the population, right, in the cost function. Evaluate the population and find the best solution. Okay, so for I equals 1 to population size and costs I equals cost function solution I, or population I comma colon, which means the solution I. And if to find the best solution, I'm typing if cost costs I, or the cost of the solution I less than best cost. So before that, we gotta define the best cost. Best cost equals infinite for now, for minimization problems, and costs I less than best cost, and best cost equals costs I, and best solution equals the solution I, or population I comma column, right? So let's run the code, and the best cost is here, best solution is here. Okay, the next step is the main loop or iterative loop for iteration equals 1 to maximum number of iteration. In the main loop, firstly, we gotta update R1. Update R1 for each iteration. So R1 is calculated by this formula, and a minus t is the current iteration, and iteration times a divided by capital T is the maximum number of iteration. So a divided by maximum number of iteration. Okay, so the next one for each solution and for each dimension. Okay, and which means for a 4 in 4 loop, for I equals 1 to population size, and for j equals 1 to dimension. Okay, and firstly we gotta update R2, R3, and R4 parameters, and update R3, R2, R3, and R4. R2 is a random number in the range of 0 to 2 pi, right? So I'm typing 2 times pi times rand. It produces a random number in the range of 0 to 2 pi, and R3 equals R3 is a random number in the range of 0 to 2, and I'm typing 2 times rand. Okay, R4 is a random number in the range of 0 to 1, and I'm typing directly rand. Okay, so the next one, update the solution, update the population for each solution and each dimension, and update equation is here. And there is a condition, if R4 less than 0.5, this equation, or otherwise this equation, right? So I'm typing if R4 less than 0.5, the first equation. So xit or xit is a position of the current solution in the dimension I at iteration t, right? Xi is the solution I. So population solution I comma g, the dimension g of the solution I, right? So the same thing, the population I comma g plus r1 times sine r2 times in absolute value r3 times pit. Pi is the position of the destination point in the dimension I. So the destination point, which means the best solution, right? So the dimension g of the best solution. So best solution j minus xi, right? Your solution I, population I comma column, or I comma g. So okay, the first equation is here, and the otherwise or else, not sine, cosine, and okay. We will update the solutions, and the next one, we gotta control this population whether it's inside the boundaries, right? So control the population whether it is inside boundaries, right? The boundaries. So for I equals 1 to population size, and population I comma column or solution I equals minimize population I comma column or solution I, and the maximum value or upper bound. Okay, second one, maximize and lower bound. Okay, the next one is evaluating new population and updating the best solution, right? So evaluate new population and update the best solution. Okay, I'm copying here and paste. So we have evaluated the population and updated best solution and best cost. Okay, so the next one, we can print the iteration information, right? So print iteration information fprint f iteration d iteration, right? So okay, after the main loop, last one, reporting the best solution or best cost, right? So best solution and best cost here. So let's run the code and The best solution is here and best cost is here. Iteration information. Okay, if you wanna plot the convergence curve, we gotta define the best cost array, right? So best costs for convergence curve, right? Best costs equals zeros 1 comma and maximum number of iteration for now and best cost, right? So convergence curve best costs iteration equals best cost. Okay, so I'm gonna use semilog y common in MATLAB. Semilog y best costs and grid on. Okay, let's run the code and here it is. It's the convergence curve of the SCA for the spare function, right? So best cost, best solution is here and best cost is here and the convergence curve is here. Okay, that's all. Thank you for watching and see you the next video. Bye.